Okay, in this video we're having a look at a rotator controller that I did a couple of years ago that was basically done for a customer. I never actually got around to doing a video for it and to show all the upgrades and stuff. Well, this is things have changed for him, and it's come back for a tidy up and basic service and to be sold off as things he's been changing everything to a different rotator and bigger aerials or something like that. So basically I thought, well, now's the opportunity to have a look at the controller and the upgrades I did to it, yeah, then it'd be plus it'll be good for the sale part of it as well. So it's a CDE controller which has had a lot of upgrades, mainly the motor start capacitor has been moved from the rotator to the controller to the rotator. That's the major thing, which has saved me 2 wires on the control cable. So then I separated the motor neutral and the solenoid brake neutral and used pin 4, which is one of the saved wires from the motor start capacitors. So now this rotator controller uses a 7-cord trailer cable, much more available here in Australia. So basically what we're going to do is I'll just quickly give you a bit of a quick run around on the upgrades that have been done to it. So on the front panel, if we don't get this flaring out too much because it's a silvery gold front on it, so we have the original switch on these CDEs was a rotary one used to rotate. So that's been replaced with an illuminated switch, and if you look closer, get the light in the right direction. The center switch for the brake has been removed, and it now has auto brake release, and we have in their place they've been repositioned, and in their place I've put LEDs, so left LED, brake action LED, and right LED, which is over in there. The calibration pot was changed, which is the pushing one from the front. It actually has a little LED to tell you when you're in calibrate mode, which is done from the switch at the back. The panel meter is the same as it always was, but is now LED illuminated. We'll get inside that in a minute. On the side here I'll replace the imperial screws with metric screws, as I do. On the back panel, which I've done on a lot of these rotators, is I've got a stainless steel mirrored or brushed mirrored stainless steel backing, which is etched, so you can probably see the etching in here for the sockets and the operation, and basically earth post and stuff, so IEC socket, etc. So we shall go ahead and we'll turn him around and we'll lift the lid off. I like these ones because they're all metal instead of the plastic ones. So we'll take the bottom off as well, and the bottom has new feet in it. I found these feet at a local place, and they're not stick-on. You drill a hole and you push them inside and you put a little pin into the bottom, which makes them more positive and they don't want to fall off. So okay, so the main thing you'll see in here is it's running a toroidal transformer. It's a 160 VA, if you can probably can't read on the side here, well, probably only just. It's a 160 VA, so it's 6.4 amps. So these brakes are pretty thirsty, and the motor as well. So basically toroidal transformers like inductive loads really well, so we'll just get up like that. And then the actual display has a new 240 volt primary transformer, 15 volts out for the display side of things. So basically that's what when you look at things like that, and then you can see the actual pot here. I might even turn it around for that one, might be easier to see. Back of the pot is there, and the LED sitting up in there, and the actual switch for it's there. And what I've done is I've only used one side to switch the actual calibration point in, and the other one just switches the LED on, because these switches have double throw. So I mean, I could actually tell you, so it actually tells you when you're in calibrate mode if you happen to bump it. So we have a ferrite on the beads on these, like they do on the later versions. The only thing that I did with this when I got it back is I replaced my prototype PCB with my current version, which is now in production. This board, I'll turn it around again, was developed up from that prototype, and basically it is now all finished, all terminal blocks, no soldering necessary, and I had to cut away parts of the chassis to get the fit in because these meters are deep, so that's all good. So if I spin around, you can actually see the switches in here, well not the switches, the levers for the switches. It's probably pretty dark. So okay, and it's been repositioned some extra holes there. So we'll turn him over, and on the bottom you might notice we've got a plate here. This was actually part of the rear panel, which I've actually repurposed as to cover the big hole in that's there for the original the IE transformer, and basically it's been reused. So basically that's what the plate's all about, and that holds the transformer. And I put a insert in here, a thread insert. It's a self-clinching nut, so I just screw it down and that's in, and the self-clinching nuts there and there. And as well on the inside here as well, there's self-clinching nuts in there as well, and down the side here to hold the back panel on. So it's all been neat and tidy, and you can see there, this thing's getting heavy, that transformer's really heavy. So there we go, we have the actual switches in here, and double clicking. How do I do this? So do it that way, and then the other one does that way, so they're in dual action. So brake first, then direction. And below that is my brake delay PCB, auto brake PCB. This is an upgraded version of the one I've been doing. Did a few upgrades, and it's I'm going to put this upgrade into production this year. So it's just using up all the older stuff first, modifying that, and then moving forward. So basically, you can see the bottom of the board. It's a DS-2HG, HG for HyGain. That's flared out. So okay, there we go. So basically, it's all there. So this board has it's just a standard board, but it also has filters on the inputs to the meter, and the normal configuration for the HyGain stuff. But it has a 12-volt output for driving the LEDs, and that actually goes by you can see the bridge rectifier down here. And basically the rest of it's up in here. There's a 12-volt voltage regulator up in there. So that's how I'll drive the display. So the brake delay is selectable from 3 or 5 seconds by this little pin selector here. So you can make it either more or less. And the 2 capacitors are for the delay part of it. So must admit those toroidal transformers are only heavy. Try to hold up like that. Okay, so what we'll do is we're going to drop him back into the base again without scissoring my fingers off. Just get out of the road. I might leave it over there actually. And we'll have a quick look at the base of the rotator in a minute. The rotator's got my new stainless steel one-piece mask clamp. Just put a step in it to stop from bending from the side. I'll get it in line, would be a good idea. You see it's rolled down, 3mm stainless or folded up. Stainless steel U-bolts. There's it's motor start capacitors inside, and a few other upgrades inside. I probably should do a video on that one of these days. We have the cinch socket in here with a little cover plate that I had made. The bolt holes have actually been had recoils put them in, so the original whatever screw size, what they 5/16, they actually were drilled out and recoils are put in, so they're metric now. I replaced the terrible flat bladed screws that hold the chassis together with a super long Phillips head version. A lot easier to do up. So yeah, it's again, that's pretty heavy too as well. And we have, and the same thing, I'd put recoils up in here to 8mm, no 6mm, so 8mm I think they were, 6 or 8mm, I can't remember what it was now. So it's been a while since I did this part of it. So there we go, getting back over there. We're just going to take a bit of a drive as well. So we feed this back up through here. My little test cables here. Quickly wire him up, and we're just taking for a bit of a drive. See, it's still all working. The plug on this I've actually got sitting at an angle, so we get past, if you want to put a lower mask clamp on here, oops, if the plug's on a bit of an angle, that's to get past the, if you put a lower mask clamp on, to get past the clamp and still be functional. So there we go, let's back up, let's put him back over there. I had to put him up on this thing to get it so the plug doesn't. Okay, we'll plug ourselves in, give it some ergs, put it into there. Go the right way, right here, make sure there's a north. Oh, that didn't go in its rightful place. So, oh, the screw's done itself up, that'd be about right. There we are, that's better. So, okay, right, we'll just leave the top off for now. Okie dokie. Get this, please, so we can see. Turn him on. There we are. So there we go. Oh yeah, and I might have to put the top on because the light was telling me the calibrate light was on because the light shining down from the top. There we go. I'll leave it like might see things a bit better. I had shadows, but I might put something underneath that to physically hold it up, so we can see it a bit better. There we go. That might make it a little bit better. Okay. Can't really see the rotator that much, but I might just bring him up a little bit. Okay, he's on. You'll hear the brake if I just partly push down. You hear the brake click in, 3 seconds it will click back out. And then we'll go for a drive. There we go. And we'll just stop there, so we have 3-second delay before the brake is engaged. And then we'll go again. Coming in through west. The rotator itself was strip cleaned and everything else, and then glass bead blasted, and then it was edge primed, and there's the south now, and the brake kick in, and then it was edge primed. And then painted in this silver. All the two casings were in pretty good condition, being the Ham2-4 ones, later version. So on the inside that is. So yeah. So basically, I stripped it down, cleaned it out just for the sake of cleaning it out, make sure it's all 100%, and basically re-greased. I re-shimmed the gears as well. Just things I've done later on. I've gone through north. Oh, we'll just stop in there for a second. Let the brake kick in again. There it goes. You probably can't see the actual LED is actually on down there now. You probably cannot see it because there's so much light here. There we go. So, but yeah, it's coming around to south now. There we go, we're at south. Let's brake again, we'll come back to north again. So everything's working fine, and as I said, this rotator controller will be up for sale when I get the rest of the photos taken and get the ad going. So I'll come out to east again. We'll stop at east with the brake kicking again. Much easier when you haven't got to hold down 2 buttons. Coming back up, there's 60 degrees, 45, 30, there we go, 15 degrees, and basically we are back at 0, smack bang on 0, so there we go. Now there's a bit of a look around of a CDE upgraded controller controlling a Ham2-4 rotator. Catch you next video. Bye. Oh, I'll pan up, that's what I'll do, I'll pan up, you can see up there, and we'll pan back down again. Catch up.